Hello everyone, welcome to today's lesson, Chapter 9, Data Structures, Stacks and Queues using List. In this particular class, we are going to see the introduction of what is a data structure and elementary data representation and stack. So what is a data structure? Before I go into the definition here, see we deal with, in computer science we deal with lots and lots of data. So like whether we wanted to store any information or whether we wanted to retrieve any information from a system, so data structure really played a very important role. It helps us to represent, store or organize, process and manage information. uh, so according to the definition, data structure is a named group of data of different data types which is stored in a specific way and can be processed as a single unit. A data structure has a well-defined operations, behavior, and properties. The data that we collect can be a raw data or a raw facts, which are just simply values or set of values, or this data item can be presented in certain type. All right, so that is the main definition of your data structure. So data structure is mainly divided into two types. One is simple data structures and compound data structure. So data structure, what we have learned so far in our classes, mainly we deal with array or linear list, and we know that in Python it supports not only lists but other data types or data structures like tuple, sets and dictionary as well. Here though I've mentioned only array or linear list, but we know that Python support other types of data structures as well. As I mentioned, tuple, sets and dictionaries all come under your simple data structure. Whereas in your compound data structure is again divided into two types, linear and non-linear. So under your linear, in this particular chapter, we are going to learn about your stack and queue, and a little bit of kind of explanation or introduction of linked list will also be given. And just to let you know, in this class 12, you're not going to study in detail about linked list or tree, but just to be the basic, you need to know what you need to know will be covered here. So in this chapter, we are going to cover mainly this stack and queue. So what exactly is a stack? A stack can be defined as a data structure which refer to lists of stored and accessed in a special way where LIFO technique is used. That means last in, first out. Just like a stack of, the example given here is a stack of plates. Like plates, when we have to put the first one at the bottom. Suppose if I put, and again on top of that, if a new plate I want to add up. So that is an example, a live kind of example that I can give you how it works. Okay, so plates are inserted, and it's possible to insert only from the top. Okay, like you can insert only at one end. It's not possible to insert from elsewhere. I mean, otherwise your plate may break. So that is an example of a stack. So what are the operations that we can perform in stack? With the two main operations that can be performed in our stack, we call it as push and pop. Push operation means insertion of element in a stack. Like suppose initially here, the stack is empty, so we call the topmost element of our item as top. So it is possible to insert only at the top. Okay, so a particular condition may happen, like suppose if I have only four size of an array. Suppose here I've inserted 32, 18. Like suppose if I have another two elements, 2 and 5, let's say. So if the size of my array is 4, then it's already full. And then if I try to insert another element in my stack, then a condition will happen or an error will happen saying that your stack is overflow. So it's not possible to insert if our stack is already, if it's a predefined list, then it is not possible to add anymore, and that particular condition we call it as a overflow. Now initially my stack is empty. It can happen that your stack may not initially be empty as well, depending on the condition. So initially let us assume that our stack is empty, so our top is none. And then now when my stack is 32, suppose this, as I said, if this is a 4 size and 0, 1, 2, 3, so the top of my since a new item 32 is push, now top is pointing to that particular element. Now a new item is added on top of that, so now top is increasing. All right, so as I said, if it is a 4 element, then the top will be up here at the top, and then if you try to insert any more element, an overflow condition will happen, which is known as an error condition. Now in case of a pop operation, if you wanted to remove any item from your stack, then we call that operation as a pop operation. Now suppose if you wanted to pop one element, now since at the top now, the topmost is now 18, so 18 will be pop out first, will be deleted first. So in that case, 18 is pop out, so only 32 is left here. Now suppose if you pop again another item, so since 32 is only left here, so if I pop again 32, the topmost element, then the stack will be now empty. Now suppose if I try to perform this operation again to pop again, then an error will happen saying that underflow. So please remember, in case of your push operation, when you try to insert additional item when your stack is already full, that is known as overflow. Whereas if you try to delete any item from an empty stack, that is known as a underflow. Okay, so these are the two conditions which you can be asked, differentiate between overflow or underflow, or in which condition does overflow happen or underflow happen. Those questions can be asked to you, so please note that. Now let us see some exercise here. Now suppose we have let's say the capacity of our stack is 4. Initially it's empty and we are supposed to draw pictures of the stack. Let's say, see, empty stack, then you will push A, then push B, push D, pop, and then push D. So let us try to perform this operation. So initially your stack is empty, so your top is none, no item is there. Now we are pushing A, so in the on the topmost, so my top is now 0. Now again, if we are pushing B, so now the top is increased, it will be now 1. Now when I push again C, now it will be added a new item, so the top is now 2. Now again we are supposed to pop, and then so now currently your top is at 3, is at 2. Now suppose if you are popping any item, you are supposed to pop only from the top position. So you will pop C. So now the topmost will be now decremented to 1 now. Currently now, since C has been popped out, so now the top has been decremented to, now currently the topmost element is now B, which is the position of that will be 1. Now again, if you push an item, so it's possible to add, since we still have 2 empty spaces. Now if you add 2, now the top value will increase to 2, and we'll push the item. So this is the last stack, though it is not been filled up. So this is not the case of your overflow or underflow. So since there's still a space in my stack, okay, so but then this is as per the question, you're supposed to show the diagram and after each operation what will be the last stack item. So this will be your answer for that. All right, now I wanted to give you some more exercise. This is a question I want you to perform, and then you will be submitting your answer. You can take a click, a screenshot, and we'll submit this one. Consider the following stack of characters implemented as an array of 8 elements. So I have A, G, P, N, C. Remember, now my topmost item is N. So I already have 4 items in my 8 stack. So that means 4 empty spaces are still there. Now you're supposed to find it. So you will start from 0, 1, 2, 3. Your topmost is now at 3. Now you will pop out. First you will pop and then push K, push S, push pop again and push G. So you're supposed to show me what should be your final stack after performing all this operation. All right. Thank you so much, student. That's all for today. And then if you have any doubt, you can always show me again.